continue with chapter number 18 from your economics book of grade 11, and the name of the chapter is Measures of Central Value, and today we're going to start from the median. So the median is the value of the variable which divides the group into two equal parts, one part comprising all the values greater than the median value and the other part comprising all the values smaller than the median value. That means the mid, right? Median means mid value. To illustrate, if the weight of 5% arranged in an ascending order, that is 50, 55, 62, 65 and 70 kg, the median weight would be 62, since there are two items below this value and two items above the value. Thus, median has a position at the center of the values. It divides the series into two equal parts. Median is particularly useful for the items are not capable of exact measurement. So we are going to see the method of calculating the median in the continuous series, or we can say the frequency distribution series. In the case of a grouped data, the determination of median is a bit more complicated. The value of the median is calculated with the help of the following formula. Median L, that means L is the lower class limit, it plus n by 2 minus CF by F median into C. What is n? N is the number of items of the data, that is the total frequency, and CF is the cumulative frequency up to the median class, and last is F median is a simple frequency A of the median class, and C is the class interval. Let us see how do we calculate it. For example, calculate the median age from the following data, that is example number 23. How to solve it? Simple frequency are first converted into cumulative frequency as given in the following table. So calculate the median of the frequency distribution series. In a frequency distribution, how we are going to do it? You can see that the age is given in a class interval manner: 35 to 40, 40 to 45, 45 to 50, 50 to 55 and 55 to 60. So number of teachers is the frequency we are having, that is 30, 20, 15, 13 and 27. So n is the total number of teachers, that means the total frequency we are having 105. So what is the cumulative frequency? For the first one will remain same, 30, and for the second one 30 plus 20, the value which we are having at the above, that is the cumulative frequency, you see 30, and at present number of teachers is 20. So 30 plus 20 is 50. Again 50 plus number of teachers is 15, that is 65. Again 65 plus number of teachers, that is 13, that is 78. Again 78 plus 27 is the number of teachers, we are getting 105. Now here we are going to add that the median is equal to size of n by 2 tooth item, that is size of 105. This is the n, right? N is the number of teachers, total number of teachers. 105 by 2, that is, we have to just exactly do the half, 52.5th item. So 52.5th item lies in the 65 cumulative frequency. You can see that. What is the range we are having? There we are checking in the class interval range, we are checking 52.5, right? 52.5 item M is contained in the class of 45 to 50. That is, the value of the median must lie within the range 45 to 50. The exact value of median is calculated by applying the following formula. So median is equal to L1 plus n by 2 minus cumulative frequency by frequency median into C. So, applying this formula, we are getting median, that is, first is L1. What is the lower case? The lower case, in which range it is coming? 45 to 50, as I told you. So 45 will come there, plus what is N? N means the total number of teachers. We are having 105 by 2 minus cumulative frequency. What is the cumulative frequency we got? 105. Cumulative frequency is 50. In that range we got cumulative is 50. So that is again 50 into C, that is number 5. Because C is size of the median class interval, 45 to 50 to 45. That is the interval of 5. That is what C is, 5. Now as we are solving it, we are getting the median is 45.83. Next we are having mode. Mode is another important measure of central tendency. Mode is a set of observations that at a value which occurs the greatest number of times, that is, with the greatest frequency in the series. More strictly speaking, it is the value around which the items are most heavily concentrated. This means that mode is the most common value. It may be regarded as the most typical of a series. The mode of a distribution is the value around the items tend to be most heavily concentrated. It may be regarded as the most typical of the series of the values. In statistics, mode is generally represented by the letter Z. Let us see how do we calculate it. Calculation of mode in the continuous series or frequency distribution series. In a case of continuous frequency distribution of series, let us see how does it happen. So the model case is asterisk first. This can be done either by inspection method or by grouping method. In case of inspection method, model class is taken as the class having the maximum frequency. Let us see now. Suppose, yes, we are having one example, that is example number 29 we are going to see. Following the age distribution of employees of a farm, calculate the model age. So, age in years, there is a class interval given and number of persons given. How to do the solution? On the basis of the given data, grouping table and analysis table are prepared as follows. Here we are having the table. So class interval, we know the class interval is given here. Now we have to group it. 1, 2, 3, 4, 5 and 6. So first, in the first column they are writing the number of persons. 5, 7, 8, 18, 25, 12, 7 and 5. In table number 2, we are finding 5 plus 7, that is 12, 8 plus 18, that is 26. Like this they have summed it up, the upper value and the lower value together. In the third, they have just added the values, again the upper value and the lower value, again the upper value and the lower value. Like that we are getting the 3 values. And after that we are just adding it again together and we are getting 2 values. After that again we are just simply adding it up and we are finding the same value. And by the end, again we are getting 2 values. So this is the grouping table, and in the analysis table we are just going to put the tick mark. That is the, first of all we are having the numbers, that is series we are having 1, 2, 3, 4, 5, 6, and then we are having the class interval written at the top, and then we are putting the tick mark. So which one is having the maximum one? That is 40 minus 50, that is having 40 to 45 is having 6. So we now have to do the calculation. Following the formula is used to calculate the model value. Z is equal to L1 plus F1 minus FO by 2F1 minus F0 minus F2 into C. Applying this formula, we are getting the answer. How to calculate? Calculate the mode from the median and the median relationship between mean and mode. So this is the relationship we are having. In a symmetrical distribution, mean, median and mode have a same value. In this case, the frequency curve will be bell shaped. Therefore, from symmetrical curves, the median x, mode m and median z are coincident. And in this figure number 5.1, however, in actual life, most of the distribution is not symmetrical. It is skewed. According to the frequency curve, may be skewed either to the right, that is positive skewed, or to the left, that is a negative skewed. In case of an asymmetrical distribution, the value of mean, median, mode are different. Like in the figure 5.2 and 5.3. Show the relative position of mean, median, mode for the frequency curves skewed to the right and left. So the relationship between mean, median, mode are moderately, you can say, skewed distribution, and there is a particular empirical relationship among mean, median, mode. Carl Person and has expressed this relationship as follows: mode is equal to 3 median minus 2 mode. 2 mean. Mode is equal to 3 median minus 2 mean. This empirical relationship among mean, median and mode is of great importance. In case where mode is ill-defined, or in case of a bimodal situation, the formula discussed earlier cannot be used to calculate mode. In such cases, mode can be calculated by using the empirical relationship among mean, median and mode. This is illustrated with the example given below. You can see example number 31. In a moderate asymmetrical you can say series, mean and median are 26.8 and 27.9 respectively. Estimate the mode. From mean and median, they tend to calculate mode. So using the empirical relationship, mode is equal to 3 median minus 2 mode. So mode is equal to 3, the median value is given, minus 2, mean value is also put it there. Right? So they are doing the solution and they are finding the value of mode. Hopefully you understood. Thank you.